Okay, so we're asked to find the greatest common factor and factor it out two expressions. Didn't make a whole lot of progress in this, so let's see what we have. We're going to do a couple of examples, and we'll come back and do these. So let's just take 12x to the fifth plus 20x cubed. Using the distributive law, I could write this as 2 multiplied by 6x to the fifth plus 10x cubed. Do we agree? If I multiply this through, 2 times 6 gives us 12. And since we have the x to the fifth, we're going to get 12x to the fifth. And 2 times 10x to the third is 20x to the third. Okay? Now, I could also factor out, I could also factor out 2x. Now, if I factor out 2x, what would go in here? Okay, now it turns out that this is equal. We could write this as 2x times what? Well, we're going to have a 6 because 2 times 6 is 12. We're going to have an x to the fourth because x times x to the fourth is x to the fifth. And here we're going to have a 10x squared because x times x squared gives us the x cubed. Now, I'm afraid we're seeing some difficulties with the distributive law itself. So I'm going to abandon this exercise here. We're going to do a few expressions using the distributive law. And of course, you're behind in the homework. Really need to catch up on that and get what Open Math has to tell you about distributive law and so forth. Okay. So I'm going to just write a few expressions. Let's say we got 4y squared times 6x y cubed plus 3x squared y. Okay. What do we get when we multiply that out? Okay, well, what we get is we get then 4y squared multiplied by 6x y cubed plus 4y squared multiplied by 3x squared y. And you probably ought to write out this intermediate step so you don't lose something. And so that you reinforce the meaning of the distributive law. Okay, well, then 4 times 6 is 24. Y squared times y cubed is y to the fifth. And you've still, of course, got your x. Okay, then this will be plus 4 times 3 is 12. Y squared times y is y cubed. And we have an x squared. And I think everybody pretty much got that. It's kind of easy to overlook the fact that you have a y to the first power here. And I think somebody wrote a y squared there. Clearly you've got a y times y here and another y here. That's going to be a y times a y times a y, which is a y cubed. Okay. Let's try. Try this one. Okay, so, did pretty well here also. So this equals 3x cubed y to the fourth times 4x squared y cubed plus 3x cubed y to the fourth times 5xy. And now 3 times 4 is 12. We have an x cubed and an x squared, excuse me, x to the fifth. Y to the fourth times y cubed gives you y to the seventh. Then here, 3 times 5 is 15. X cubed times x, well, that's going to be x to the fourth. And a y to the fourth times y, well, it's going to give you y to the fifth. Now, you can't go any further than this. X to the fifth, y to the seventh is not the same thing as x to the fourth, y to the fifth. There might be, and there certainly are values of x and y for which this and this would be equal, but for most values, they wouldn't be equal. So you can't add the 12 and the 15 and then do something with these terms. You're done. You can't go any further here. These are unlike terms. They can't be combined. Okay, well, now that we hopefully have the gist of this, let's try writing 16 x squared y cubed plus 18 x cubed y to the fifth as a product of some term and something else. Now, hopefully, the term that you would write out here, in other words, we want to take this, which is like in this form, and we want to write it like this. Okay? We want to do this backwards. So what could you put out in front here, and then what would you have left in the parentheses? Unfortunately, I didn't record that, but okay. So go ahead and try to answer my question here, and I'll build up to it. Okay. So we can pull out 2x, okay? And then we would need an x here to give us the x squared. So 2 times 8 would give us our 16. X times x would give us x squared. And then we'd have our y cubed, and that would work. And if we did a 2x here, then we'd have to have a 9 here, for 2 times 9 gives us 18. X times x squared would give us x cubed. And we'd have our y to the fifth. That's good. Well, we could also write this. I kind of crossed this out. It's not wrong because all I asked you to do was factor something out. But we could factor more than that out. We could factor out a 2xy. Okay. So we could have 2xy times what? Well, 2 times 8 is 16. So we've got to have an 8 there. X times x gives us x squared. Y times y squared gives us y cubed. So we could have an 8xy squared in here. And then to get the 18x cubed y to the fifth, 2 times 9 would give us 18. X times x squared would give us x cubed, and y times y to the fourth would give us y to the fifth. So if we pull out a 2xy, another way of looking at it is that leaves us from this one, if we pull out 2xy from this, it leaves us 8xy squared. It has to be multiplied by 2xy to give us this. And if we pull out a 2xy from this term, it's going to leave us a 9x squared y to the fourth, since 2xy times 9x squared y to the fourth gives us 18x cubed y to the fifth. So we could pull out a 2, we could pull out a 2x, we could pull out a 2xy. Well, there's more. What's the most that we could pull out in front? What's the most that we could write out in front? So we would have some term out in front and sum of 2 terms here. Okay, well. If we look at these two terms, two is the biggest number we could pull out because we would end up with 8 and 9 don't have any factors in common, so it's gotta be two. Now we could pull out X. Is there a bigger power of X that's in common between these two? Well, yeah, we have an X squared here, right? And an X cubed here, so we could pull out the X squared. And then we have a Y cubed here and a Y to the fifth here. Well, it turns out we can pull out then 2x squared Y cubed. And what do we need in here? Well, to multiply 2x squared Y cubed to get 16x squared Y cubed, we just have to multiply by 8. And then to get 18x cubed Y to the fifth, we would need 9. 2 times 9 would give us the 18. X squared times what would give us x cubed? Well, it'd have to be x squared times x. And y cubed times what gives us y to the fifth? That would have to be y squared. And we can verify that if we multiply this out, we do get this. Okay. Well, that's what the homework was about. So let's try to apply those ideas to these examples here. What can you do with each of these terms? Okay, so give this another shot. Okay. So let's look at each of these in turn. We have 4x to the fourth minus 8x cubed plus 6x squared. There's clearly a 2 that's common to all these. So we certainly could write 2 out in front. Well, there's x common to all these, so we could certainly write 2x out in front. But actually, there's an x squared common to all of these. So we could actually write 2x squared out in front. And then what? If we have 2x squared here, what more do we need to get 4x to the fourth? Well, we need another 2x squared, just by coincidence, because 2 times 2 gives us 4, and x squared times x squared gives x to the fourth. And then to get 8x cubed, we need minus 4x. It's 2 times minus 4 is minus 8. X squared times x is x cubed. And then 2x squared times what gives us 6x squared? Well, that's pretty clearly 3 because 2x squared times 3, 2 times 3 gives us 6. And we have the x squared. Okay, so there we have it. Okay. Now, in 12 x squared y cubed plus 8x cubed y equals what? Let's look at what these terms have in common. Okay, you could take a factor of 2 out of this. Matter of fact, you can take a factor of 4 out of this because 4 divides 12 and 4 divides 8. So we have 4 there. We have an x squared here and an x cubed here. Well, we can't take an x cubed out of the x squared, but we can take an x squared out of the x cubed. So we have 4x squared. And then what do we have? We've got a y cubed here and a y here. We can at least take out a y. And that's it. That's our greatest common factor. It's the biggest number that goes into 12 and 8, which is 4. It's the highest power of x that goes into both this and this, which is just the second power, the least of the powers that we see here. and the highest power of y, which is just the first power. Then we can write out what else we need. We need 3 here because 4 times 3, we need the 3 to get 12. We have an x squared, so we don't need anything more. We've got a y, but we need a y cubed, so we have a y squared. And then it's plus what? Well, 4 into 8 gives us 2. We have x squared, we need x cubed, so we better have another x. And we need a y, but we already have a y, so we don't need any more. If we then multiply this out, we get this. Now, some people want to go a little further, but there's no further you can go. And if you go further, check whatever you think your last result is, multiply it out and see if it gives you the original result or the original expression. If you don't get the original expression, you went too far, get rid of that and go back to the last one that gives you the correct expression, okay? So it's always check it. Always multiply this out and check to make sure that it agrees with your original expression, okay? Now, if you haven't gotten to this homework, you really need to get to it because we're getting into factoring and we're going to actually go to the next step here. Okay. I think everybody's in shape. If you do the homework and do it conscientiously, you'll be okay with it. But you do need, everybody needs a little more practice. Okay. Multiply this out for me, x plus 2 times x plus 3. Okay, well, we need to understand how the distributive law applies here. X plus 2 times x plus 3 means x multiplied by x plus 3, because this x is multiplied by the x plus 3, and the plus 2 is multiplied by x plus 3. Okay, so what do you get when you finish this up? Go ahead and finish it from there. Now we have to follow the rules very, very carefully. Otherwise, we get what we think we ought to get, and it might not check out. Okay, got to be very careful about the rules. What's x times x plus 3? Distributive law tells us this is x times x plus x times 3. Okay. And 2 times x plus 3 means we got 2 times x plus 2 times 3. And if we think it's anything else, we're wrong. Okay, just we're not following the rule exactly. Okay, and it's going to lead us to an error. So take this expression, what's x times x plus x times 3 plus 2 times x plus 2 times 3. Simplify that. Okay, so x times x is x squared. X times 3 is the same as 3x. 3x means 3 times x, which is the same as x times 3, so, because it doesn't matter in which order you multiply things. And then plus 2x, and 2 times 3 is 6. And we can't combine the 2 and the 6 because 6 doesn't have an x on it, and they're not like terms. We can only combine like terms. We can't combine this x squared with any of these x's, but we can combine the x terms with the x terms. We get x squared plus 5x plus 6. Okay, well, we need to talk about factoring, But first we have to understand the distributive law, okay? So we have to get really good at this. So I'm going to ask you to multiply a few others out. Let's try x plus 4 times x plus 5. Now let's try x minus 2 times x plus 3. Then let's do x minus 5 times x minus 2. And let's write these out in detail, every step of the distributive law, so that we begin to understand how the numbers that we have here give us the numbers that we end up with here. We're in a position where we really need to understand this well, better than doing just a few examples in class, okay? So I'm going to just recommend this to you, that you write down the numbers from -7 like from -7 to 7, okay? And you tear out little tabs of paper, put these on those little tabs of paper, okay? Then you randomly pull out 2 tabs of paper and do the calculation, okay? And you should do that, at least 20 of them. Doesn't take that long to do them. You get to the point where you do one in a few minutes. In an hour, you could get pretty good at this. And if you don't do that, I think you're going to have a lot of trouble understanding factoring trinomials. Okay? Because you won't understand what's going on until you really understand this pattern. I mean, when I learned this stuff, and I guess it was freshman year of high school, we had like 50 problems to do. So we learned the pattern very quickly. It doesn't take long to do them. And then you can check yourself. So for example, plus 4 times x plus 5 equals x times x plus 5 plus 4 times x plus 5. I get old writing this out every time, but it only takes a few seconds and it's well worth it because it reinforces the distributive law and what's going on, so you don't forget it a week after you learn to do it. Okay, so you get this. Now I've been talking while I do that. I don't know if I got that right or not. Actually, I kind of do. So check. Let's just let x equal 2, because that's easy. Write that out as quick as you can write it out. And if you can't, then you need to practice it. Okay? X equals 2. X plus 4 times x plus 5 is 2 plus 4 times 2 plus 5. That's 6 times 7, which is 42. And Got to write it pretty small here, but x squared plus 9x plus 20 equals 2 squared plus 9 times 2 plus 20 equals 4 plus 18 plus 20. And these are all numbers you can do in your head. And if you can't do them in your head, then you probably need the exercise. But that comes out 42. By letting x equal 2 and evaluating this expression, which is easy, and evaluating this expression, which is easy, you get the same result. And that confirms that you did it right. And if you don't get the same thing here, then you got to go back and fix this, and that helps you correct any mistakes you might be making, okay? The problem with open math is I think it gives you too much help, and you can do too much imitating rather than understanding, okay? You really need to stand on your own when you do these problems. You should not be looking back at notes. You shouldn't be looking at examples. Now, when a problem is first introduced, usually I'll have a video that goes along with it. After a while, I stop introducing the videos. And when I stop introducing videos on these things, you should stop using videos. Okay? You should rely on your own understanding to get this. And where we're going to head with this, it's just critical that you be able to do this well. And if you do 20 examples thoroughly like this, it didn't take me 3 minutes to write this out. And with practice, after you've done a few of them, you can write them out just about as quickly as I did. So with an hour or two of effort, you can master this. Okay, I'm going to leave it up to you. But open math, if you don't use it judiciously, isn't going to do it for you. Okay? If you use it judiciously, if you make sure that you really understand what you're doing as you do it, and don't use your notes and everything else on the problems that don't involve videos, unless you have to, okay? Then you learn to an extent. I would use much longer open math assignments with a lot more, people wouldn't do them, okay? You might, because you're conscientious enough to come to class and do what you're doing, okay? I'm not sure what the solution here is, but the bottom line is, for your own sake, right now, everybody's in a state where you could do this, okay? If you do it, it's going to benefit you. Okay, write these out on the tab, just pull them out randomly, do them. Okay, make some up for yourself, okay? Write them out in detail, reinforce all the steps so that they're totally ingrained, and spread it out over a couple of days. Okay, well, where this leads, we need to be talking about factoring, but we can't talk about factoring if we don't understand this distributive law. Okay, so you're right at the beginning of being able to understand the explanation open math is going to give you. You're going to be tempted to use shortcuts from open math without understanding, again, how it all comes back to just the distributive law. And well, we don't really have time. We got 5 minutes left, not even that, 4 minutes just now. The task is to reverse the process. a taste of it, so you know what to look for. So if we have something like um, x squared plus 12x plus 8, we understand, and that's their example. Okay, we'll be using this. I don't know where it came up with 8. Maybe I need to go back and do some problems myself. Okay, look, you got this. I suspect that this might be equal to x plus 5 times x plus 7. Because when I do the distributive law, I know I'm going to have a 5 times 7, which would be 35, right? And I know I'm going to have an x times x, which gives me the x squared. Okay? The question is, what do I get from the rest of the distributive law? So we understand that I could suspect that this might be a way of factoring this expression. Okay, many times there are many possible ways. Let's say we have x squared plus some number times x plus 24. Okay, now let's just say this is 14x. I'm going to cut them. Okay, could this be x plus 6 times x plus 4? Well, 6 times 4 gives us 24, and x times x gives us x squared. If I do the rest of the distributive law, do I come up with 14x? Turns out I don't. Okay. Another possibility, could it be x plus 8 times x plus 3? Again, 8 times 3 gives me 24. X times x gives me x squared. Put those terms in the middle. Do they add up to 14? It turns out that they don't. In other words, if I multiply this out, I'm not going to get this. To multiply this out, I'm not going to get this. Another thing I could multiply, how about x plus 2 times x plus 12? Bingo. Okay, this one works. When I multiply this out, I do get a 14x. Now, does that halfway make sense? Maybe not, because we had to spend all the time getting the distributive law down, right? And we weren't able to really develop this idea, and we just ran out of time. So you kind of take this idea with you. We'll talk about it next time and see how well you can get the homework done. See how well you can do on the assignment. And how well you can understand this process.